Hello everyone, in this exercise of the SolidWorks, we will create a sheet metal tray in SolidWorks as shown in the drawing. This is a drawing. These are the three different views: front view, top view and the right hand side. You will see the thickness of the sheet is 3 mm and outer dimension of this is 750 and width is 512. That is for inside flanges. Okay, height of this flange is 350 mm. Okay, these are the holes, different type of extrude cut, and sheet thickness 3 mm. You will see here is a gap of 3 mm. Okay, so let's start with file, new, part. I am selecting the background plain white and the unit system is millimeter. I am selecting the top plane. Okay, this one. And center rectangle. This distance is 750. That is the outer dimension. 750. Okay. And this distance is 500 mm. This is the 500 mm. And this is the outer flanges, which are from this outer flanges are at a height of 350. First I will take the sheet metal base flange. Thickness of the sheet is 3 mm. That is the reverse direction. Okay, upside. Dimension will measure from the bottom. Okay, this one sheet metal radius is 3 mm. Inside, this is 3 mm is the inside band radius. I will show you. Okay. Now, edge flange. This height is 350. This height is 350. This height is 350 mm. This band is outer virtual shaft and metal is inside. Metal inside. Radius, inside radius is 3 mm. Gap is 0.50 between the flanges. This is, you will see band is inside, metal is inside, and the height is height from the outer virtual shaft, means intersection of the outer edges and the intersection point up to the end of the flange. This is the height, that is the 350 as per drawing. Okay. If you measure the height, evaluate, measure, radius is inside radius is, you will see 3 mm. Okay, and height is measure, you will measure this one. From outside, this one, and 350 delta y. This is height from outer virtual shaft is 350 mm. Okay, this one. Now, if you go in the drawing, this drawing, this you will see these flanges, this at the length side. This dimension I have taken already 750, and these flanges are at a height of 175. Okay, but you will see there is a gap of 3 mm and metal is outside, and there is a band, there is an offset of 6 mm. Total width is 520 mm. These flanges, these two flanges is outer dimension is 520. I will show you how you will window part. Sheet metal, edge flange. this distance, okay, and this distance. This is the 170 mm height, 170 mm height, and outer virtual shaft, and band is outside. This band is outside. Band outside means this width will be increased by 3 plus 3. In addition to it, there is an offset of 6 mm. This is the 6 mm offset. 6 mm offset. This is the 6 mm offset. It means 3 plus 3 plus 6. 12 mm will be increased. This flange will be moved on one side. The same way, 12 mm will be moved on the other side of this thing. So total length will be equal to the 520. I will show you this thing. I'll take right view, this one. If you take the distance between this and this and this is the 525 port. Okay, yes. I have given the offset of 6 mm. Sheet metal, right, this one, and inner band, if you measure, this will be equal to 3 mm. Inner band, this is 3 mm, and outer band will you, if you measure, that will be equal to 6 mm. Okay, okay, there is a offset of 6 mm. If you measure, offset is a 6 mm. This is a 6 mm offset. Okay, now there is another flange. If you you will see in the drawing window, you will see there is another flange. This at a distance of outer edge up to 60 mm, and height of this flange is 165 mm. I will show you how you will do. Sheet metal part. Sheet metal, edge flange. This one. This one. Okay. This is the outer virtual shaft. Metal will be this flange height will be measured from the outer virtual shaft, and band will be the outside. Band will be the outside, but there will be no offset in this case. Okay. If you take second added flange, but height of the flange is equal to smart dimension. Height will be equal to 165 mm. Okay, but this height is equal to, first delete it and then add it. From outer, this height is equal to 60 mm. This I will show you. Okay, back. Now this 165 mm. Blind position, but there will be no offset. Okay, uncheck it. And another flange 165. This one. This is another flange. Height will be smart dimension 165, and this side, this will be equal to 60 mm in both cases. Okay, back this one, but there will be no offset in this case also. Okay, 90 degree, 0.5 gap, 3 mm inside radius, but band is outside. If I check it, isometric view and right view, you will see, if I check them, if I measure this side, this height, this one, this is the 512 mm. Okay, this is the 512, and this height, if you measure from this end to this end, this is 170. Sorry, this height, this height 165. Actually, this height is 165. This is 165 outer visual shaft, and this height, evaluate, measure this. This is 175. This is 175. Sorry, this is 175 actually. 175. This one. This side is 175. Okay. Evaluate, measure, decide. 175. And this is 165. This height is from here, this side, measure this side and this side. This is from $159. About 159 plus 6, because there is a radius, inside radius 3 mm, and from bottom this is a 165. This is from this edge. Okay, if you measure from here, this one, from here 165, this side is 165. Okay, now it is clear. Now this one, select this face, this one, select this face, sketch. We will make a, as per drawing, there are the two holes here. Right, another hole. This one, select this shift equal, and smart dimension, this is 25 mm, and this is 25, and from this is height is 25. And this circle dia, this is 15. By default it is. And one more relation, this shift and this sheet. This is the vertical relation. So sketch is fully defined. Okay. Sheet metal, extrude cut, through wall. Let's see the cut. Curve cut will take place. Now mirror, future, mirror. From here, I will select the cut extrude directly script and the edge flange. Edge flange, mirror, about right plane. This one, and edit this one. Edge flange also select. Cut extruded and flange. This is the you will see there is. Okay. Now break corner, sheet metal, break corner, this one, this one. This is the both. You select both the faces and define the radius, fillet 100. You select the face. For the break corner, you can select either edges, these edges, you can select these edges, or select the whole face and you fillet will be applied. Okay, this is this one and this one. Okay, now there will be another flange. If you see the drawing, sheet metal drawing, you will see this is a flat and there is a flange, this one at a distance of 60 mm. This circle, this radius 40 and circle diameter this one. You will see there is a gap of 3 mm here, gap of 3 mm, and this outer flange dimension 0.24 and this is the point, and this flange I have also defined at a distance of 60 mm and this one, and this height is 165 mm. Okay, now I will make this upper flange. There is a this one. You will see there is a auto relief also. I will show you. Part. Edge flange. This one. 90 mm. Okay. And metal is inside. Metal inside. Added flange 3 mm inside radius, and this one custom auto relief I will apply this from here. That is the if I uncheck use relief, 1.50 will be the width and 1.50 will be the depth of the auto relief. I will show you. Added flange, this one. Added flange. This one. Take the 3-point arc. This one. This one. This one. This one. And this is the 40 mm. This is the 40 mm. And this dimension equal to from here 60 mm. As per drawing. Okay, and there is a circle of 25 mm here. There is a circle of 4. Okay, top normal. This one. Underdefined 40, this one, and this circle dimension is 25 mm. But there is one thing, isometric top or normal. Edit flange. If I back, edit flange, this one. If you take the line, this one, of this line, and you will take the midpoint. Yellow color is the midpoint. Join it. This one, and this, select this line and vertical line. The sketch is fully defined. Back. Relief. Either use relief ratio 0.5. This 0.5 means 0.5 into 3 mm. It means half of the sheet thickness. Or uncheck this thing. Width is 1.5 and 1.5. I will show you how this. Okay. I will show you. This one. This is metal inside. Metal auto relief will be applied when the metal is inside. Okay. This one I will show you. This one. This auto relief. If you measure it, this will be the depth 1.50. Okay. And this will be this is the depth, this is the width. Sorry, this is the width 1.50. And this will be where the band ends and this start. This is the 1.5. This is the depth and this is the width. Okay. And this way you can apply the auto relief is very essential in during bending. Otherwise, there will be tearing of the sheet or deformation of the sheet, or there will be dimples, wrinkles, etc. Defects will be there. So auto relief is provided for that purpose. In order to prevent the deformation and tearing of the sheet, auto relief is provided. Okay, this one. Now you can mirror it. Mirror it. This one, mirror it. Mirror about right plane. This one, right plane. Future to mirror. This one. From here you can select. Break this edge flange. Okay, and this one. This you can. This one. Select. Now another is we have to provide the slots here. Select this face, this one, draw a line here. This one. This is 6 mm. This is 6 mm, and this is the 75, I think. Or this one we can see here in the drawing. This is 6 mm. Distance is this one, 75 mm. Okay. This one, and distance, if you mirror it, and this distance from here to here, 130, and this height, so this height is 80 mm. And if you linear pattern this sketch, linear pattern, linear sketch, clear? This one, 4 mm. And this distance, if I take 70, 4 pattern about this thing. Okay, at a distance of 70 mm, 4 pattern along this line. Okay, now again mirror quantity, select this one, all about mirror, make sure this should be copy. This is okay, and this one, slot into it. And another thing, you can make, we have to make 2 holes also here, 2 holes also. This one, we will make in one attempt. this one, select this, shift this one, horizontal. Okay, this dia is 15 mm. Again 15 mm. This one, and distance 15 mm. And this height is equal to 25 mm. Okay. So now sheet metal extrude cut through all. This one, in this way, this one. I have shown, I have made all the things in this one. We actually in this exercise of the sheet metal, we have made we have understood the edge flange regarding offset and bend outside and the slots, and these are the edit flange and base flange and slots in this way. So this is generally used for the industry for the actually tray purposes. In this one you can flatten it also. This one you can flatten it, or if you for cutting purpose you can give in the CNC computerized machine, you can save in the DXF format from this one, because this format is applicable. File name is drawing only. You can save it. DXF format. DXF format is applicable in the computerized machine for the CNC machine. For the AutoCAD purpose, save this one. There is a window appears. You select the sheet metal, whatever parameter you can select, band lines, etc. Bounding box. This is the outer bound. In this way, you can save it and save it. And I hope you would have enjoyed in my this exercise. You please like, share, and you please subscribe my this channel to grow up to a great extent. And thanks for watching. Thank you very much.